কথাগুলো যে
জি
শুনতে
স্যার,
পাচ্ছ কিনা,
অবশ্যই।
আদারওয়াইজ আমার সাইড থেকে তো আমি বুঝতে পারতেছি না যে তোমরা শুনতে পাচ্ছ কিনা। অনেক সময় দেখা যায় আমি ক্লাস নিচ্ছি বাট টেকনিক্যাল কারণে ওই পাশ থেকে তোমরা কিছু শুনতে পাচ্ছ না। হ্যাঁ, সো ইউ জাস্ট রেসপন্স যে
ওকে
you
স্যার।
guys are listening or not. Well, so regression analysis, basically a supervised learning algorithm, supervised machine learning algorithm. So in regression analysis, we try to find the relation between dependent and independent variables. So dependent variable is y, independent variable is x. So y is numerical. So in regression problem, the y is numerical. Say for example, we can look for price or sales something. So we start with a simple linear regression. So we had an example like x-axis shows the number of experiences and y-axis shows the corresponding salary. That for these, um, if you have a 2 or 5 years of experience, then what will be your salary? So that's basically the y-axis. So to solve this simple problem, we have the equation here, equation 1.1, that is y equals to intercept plus slope times x. So x is here independent variable and y is here dependent variable. So if we can find omega 0 and omega 1, which is intercept and slope, then for any value of x, we can easily find the value of y, right?
Yes sir.
Right. Here, response করতে হবে. So now you can see from equation 1.2 to equation 6 that we can calculate, how can we calculate the intercept and slope? So intercept is basically y bar minus slope times x bar. And to find the slope, which is basically r, correlation coefficient, times standard deviation of x and standard deviation of y divided by standard deviation of x. So in the next class, next physical class, I will show you another technique that without calculating standard deviation, even correlation coefficient, you can also find the value of slope. If you have the value of slope, so easily you can find the value of intercept. So after this, we saw an example. So this was the first example, table 1.1. So in the example, you see we have input and output, x and y. So x is independent variable and y is dependent variable. So here in table 2, we simply calculate some other stuffs like x minus x bar, y minus y bar, x minus x bar times y minus y bar, x minus x bar to the power square, y minus y bar to the square, and their sum. So why we need this? Because we try to calculate the correlation coefficient and standard deviation of y and x. To calculate the r and standard deviation of y and x, we need to find these values. That's why we calculated these values. And after having these values, we can easily find slope omega 1, and after having the slope, we can easily find intercept omega 0. So when we have the value of intercept and slope, we can put them into this equation. So for any value of x, we can find the y. Say for example, if x equals to 3, then y will be 250. Is it clear to everyone?
Yes sir.
Okay, anyone has any questions about this simple linear regression concept? Okay, if not, then we can move to the next section, which is multiple linear regression. So in multiple linear regression, we have one dependent variable but multiple independent variable. So here you can see the equation 1.7, we have multiple independent variable x1, x2, xn. So the equation is same, how to calculate the to find the value of y, equation is same. So is this 1.7 is derived from 1.1. So here you can see we have intercept, we have slope times x1 plus slope times slope 2 times x2 plus dot 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 slope n times xn. So we can simply write this equation like omega 0 plus summation of I 1 to n omega I times xi. So that's very simple thing. So here, what we have to do, as like the previous example, we have to find the weights like omega 0, omega 1, omega 2, dot, 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 omega n. So here we have an example which illustrates the concept of multiple linear regression. So if you look at the table 1.3, then you can see we have two independent variable x1 and x2 and one dependent variable y. So this the data we collected taken from past. So now based on this data, we want to predict y for any value of x1 and x2. So we can use the equation 1.8 to find the slope. So same equation like the previous one. Y bar, which is the average of y, minus slope 1 times x1 bar, which is the average of x1, minus slope 2 times x2 bar, which is the average of x2. So now to find the value of omega 1 and omega 2, you can use equation 1.9 and 1.10, and you see the 1.9 and 1.10 is about small x, so we need to do another further step, go for another further step like uh, small x to capital X. So our column is about capital X, x1 and x2. So it makes the relation like if I equals to 1, then summation of x I to the power square, which will be like this. So equation 1.11. Similarly, you can find summation of x small x I y, which is basically summation of capital X I y minus summation of x I times x y divided by n. So everything is clearly explained here. So if you sit quietly and look at these equations, then you can easily understand what is happening. So, so from the table, this is the 1.3, we can derive derive these values. So from table 1.4, we have x1 to the power square, and there sum x2 to the power square, there sum x1 times y, and their sum, total sum, x2 times y and their total sum, x1 times x2 and their sum, and also we can find the average of x1, x2, and y. So now if we have these values, we know all these values, we can put them in the equations and we can easily find omega 1, omega 2, and omega 0. So after having this value of omega 1, omega 2, and omega 0, we can find any we can find the value of y for any value of x1 and x2, and that was the example of multiple linear regression. Any questions with multiple linear regressions?
No, sir.
Okay, great, thank you. So then we talked about how can we calculate the error of a regression model. Say for example, if you look at the red line, the slope, red line is called slope or is called regression line or decision line. So if you look at the red line, then you will see each of the blue dot is the data point, or in instance, if you want to predict this, particularly these examples, say for example xi, the regression line tells the predicted value is here. If you look at my cursor, then you will see this is the predicted value, and which is y I, which is y hat I, and actual value is not here, actual value is here, so which is yi, which is observed value yi. So this the gap like yi minus y hat I is basically the error. So this is, we calculate error for a particular example, particular instance, xi. So this is the error calculation of a one example, one instance. But if you want to calculate all of them, then we can actually use summation technique. So you can calculate all the errors and sum them to get total error. So here we have a one formula called method of least square, which is summation of all errors. So we consider each data points and to find their error, which is y minus y hat to the power square. Is it clear to everyone?
Yes, sir.
Thank you. Still today, I'm suffering from cold. So if anyone uh, don't understand my language, please raise your voice. I will repeat that thing again and again. So after um, knowing the multiple linear regression, we discuss about multivariate linear regression. So in multivariate linear regression, the situation is like this: we have multiple dependent variables. In previous case, when we talk about multiple linear regression, we saw we have one single dependent variable, but we had multiple independent variables. But here in multivariate um, linear regression, we have multiple uh, dependent variables. Now you see here multiple dependent variables. So these multiple variables are y1, y2, yq. So you have a yq number of uh, multiple dependent variables. So how to solve this problem? We can simply use simple linear regression concept or technique to solve this problem like this one. Say for example, if you look here, y1, y2, yq. So these are the same formula that we have for multiple linear regression. So by applying this concept, concept of multiple linear regression, we can simply solve multivariate linear regression. But problem is when you have a large number of q, say for example, you have a large number of dependent variables, then it will be really very complex and costly because time consuming and costly process. So it will occupy a large number of RAM to do computation, all things. So how to solve this problem? So we have one wonderful solution from an Indian scientist, mathematician. So the formula is x transpose times x inverse times x transpose times y. So if you find this value, then you will get the p hat, which is basically the weights omega. So this is a typos. So p will be the omega. So make correction at your class note. So these are basically the weight matrix. If you look at here, so we have y matrix, we have x matrix, we have error matrix. Epsilon is error. We calculate error for each multiple linear regression problem, and then we have b. B stands for the weight matrix. So these are the omega 10 11 p, omega 20 21 2p, omega q0 q1 qp. So these basically the weight matrix. So now we can have y matrix and x matrix. We can calculate. But here I'm showing you one simple example with two dependent variables and two independent variables. If you look at the table 1.5, then if you look at figure 1.4, then you see we need these six weights: omega 10, omega 20, omega 11, omega 21, omega 12, omega 22. So we need these six weights. If we can find these values, we don't need to go for complex um, formula. So the idea is here we have x from the table and we also have a y from the table. So for x, we have to add one additional column, which is x0, and the value of x0 is constant, fixed, 1. So we put 1, 1, 1 here. So now we can simply find this value like x transpose. So we transpose x. So you see, this is the original x. We transpose it here. So the row become column and column become row. So x transpose times x, which is the matrix multiplication. We have this value. After having this value, we can inverse it. So it will be x transpose t times x to the power minus 1 or inverse. And Also, we can compute x transpose t and y, which is also matrix multiplication. After having these value, we can find these value like our final matrix, which is another outcome of two matrix multiplication, like x transpose t times x inverse, which is one matrix. Another one is a x transpose t times y, which is another matrix. So after having these values, what we can say, we now, you see these six values in this matrix, these six values actually correspond with these biases or weights. So B10 will be 35.8, B11 will be minus 0.8, B12 will be minus 0.3. So similarly, B20 will be 2 to 9, B21 will be minus 4, B22 will be minus 1.5. So this is called, like, within very simply, not going for complex formula, we can simply find the weights, and after having these weights, we can simply put them in this formula. Now we know the value of omega 10. Here, I repeat, there is a typo. The B will be the omega, uh, omega 11, omega 12. So any value of x1 and x2, you can have the y1. If you calculate the error, then you can also add epsilon 1 or epsilon 2 with the equation that will give more accurate result of your model. Is it clear to everyone?
Yes, sir.
Any questions up to this? এতটুকু নিয়ে কারো কোনো কোশ্চেন আছে কিনা?
No, sir.
Okay, thank you. Okay, after that we talk about polynomial regression. So in linear regression, we need that data should be linearly distributed, but in polynomial regression we see the data is not linearly distributed. It's like a curve, or is a scattered data. So if we have this type of curve data represented with the curve, then what to do? Then we can use polynomial technique. So it's a bit complex. The formula is here: y equals to intercept plus slope times x plus slope times x to the power square for one single independent variable. So if you have a multiple independent variable, this formula will be really complex. Here I have shown one simple example with one independent variable x and one dependent variable y, and now you see the calculation is too complex. That's why I don't recommend you to use polynomial regression. So we have other algorithms that can easily classify the non-linear data, like deep learning that we learn after the mid exam. You can apply decision tree or Bayesian classifier for classifying non-linear data. So not to use polynomial regression. It's a bit complex. Clear? Is it okay to everyone?
Yes, sir.
Okay. Now let's talk about the matrix or formula that we can use to test the regression models. So you have multiple regression models, and which one is good or which one is not acceptable, how can you identify? So to do this, we can use R square value. So here you see the formula to calculate R square value is 1 minus residual sum of square divided by total sum of square. So residual sum of square is here y minus y hat. So y is the actual value, y hat is a predicted value by the model. So we need to calculate the total sum square, residual of sum square, sum of squares. So you see residual is a error, sum is a sum of all examples of square. So here we have square. So residual sum of square. divided by y minus y bar, which is the total sum of the square. So y is the actual value and y bar is the average of y. So this residual sum of the square we can simply write I ei to the power square, summation of ei to the power square, and 1 represent 1 or 100. So 1 minus this is basically the r square value. So for r square value, what to do? So the value is between 0 to 100. So if we have we see the regression model have 85 to 100 r square value, then we can accept it. If it is less than 70, that means the model is not good. Model doesn't fit all the data on it, so we have to ignore it. And 70 to 85 is your choice, but normally 80 to 100. If the result is 100, that means all the data are fit on the decision line, and that's why the accuracy is 100%. Is it clear to everyone?
Yes, sir.
Okay. And now we have another two parameters that we can use to evaluate the um, regression model. One is mean square error. So y minus y hat to the power sum to the sum of y minus y hat to the power square divided by n. So you see equation 1.18 mean square error, and also we can calculate mean absolute error. So here you see this is square, and now here you see this is absolute. So there's a positive value. Y minus y hat or y hat minus y, both are same because it returns the positive value. So these mean square error and mean absolute error is also known as L1 and L2 loss. So we'll learn few other parameters when we'll learn deep learning. We'll see how can we apply deep learning for solving regression problems. We'll see that after the mid-exam. So that time we may learn few more parameters. Any questions?
No, sir.
Okay, great. So now let's talk about classification. So we have done with the regression technique. So classification is another concept or similar like regression, but in regression the dependent variables are numerical, but in classification dependent variables are categorical, non nominal, non not numeric. Is a nominal or categorical. So that is the difference. Like the classification problems are bifurcated into two types, either binary class classification or multi-class classification. So binary class classification is a problem that um, we will tell either 0 or 1. You pass the game or you fail the lost the game. You pass the exam or you fail the exam, like this. You are married or you are not married. So yes, you represent 1, no represent 0. So this is called binary class classifier or classification. Multi-class classification is like the dependent variable value will be more than 2. So for binary class, we say the dependent variable value will be 2, 1, 0. But for multi-class, it will be 1, 0, 2 up to m. Is it clear to everyone?
Yes, sir.
Okay. So the classification technique or model has to go through two phases. The first one is called learning step or training phase. We train the model, and the second step is called classification step or testing step. So after training the model, we test it. If we are happy with the result, test result, then we go for further step, which is deployment. We deploy the model. We use the model in real life application. So the first step is training phase where we train the model, and the second step is learning phase where we testing phase. We test the training and testing. So first step we train the model, and second step we test the model. That's it. So today we are talking about this interesting concept called logistic regression. You see, the logistic regression. If the name is regression, logistic regression, but it do classification task. So logistic regression is normally uh, is used for binary class classification tasks. Like binary class classification means you fail or pass, you zero or you one. So binary class classification, why it is called regression? Because logistic regression uses the concept of linear regression. So linear regression, the output is passed through a sigmoid function. Like the output of a linear regression passed through a function, and this function is called sigmoid function. If the output of the linear regression is less than zero point 0.5, it returns 0. If it is greater than 0.5, it returns 1. That's the basic concept of logistic regression. Any questions? So now you can see how we can have the logistic regression formula, or better to see the sigmoid function. So how sigmoid function actually work? It shown in figure 1.21. So sigmoid function is a S function where actually we consider a threshold. Here, say for example, the threshold is 0.5. So any value comes less than 0.5 to minus infinity, it will return 0. Any value comes with greater than zero point 0.5 will be zero point 0.5, greater than zero point 0.5 to plus infinity, that will be the 1. So sigmoid function always return 0 and 1. আমরা কি বুঝতে পারছি?
जी सर
ওকে, সো যেটা বলছিলাম যে লিনিয়ার রিগ্রেশনের আউটপুটের সাথে যদি আমরা সিগময়েড ফাংশন অ্যাড করে দিই তাহলে সেটা লজিস্টিক রিগ্রেশন হয়ে গেল। সো নাও ইউ ক্যান সি দ্য কম্পারিজন বিটুইন লিনিয়ার রিগ্রেশন এন্ড লজিস্টিক রিগ্রেশন। লিনিয়ার রিগ্রেশন নর্মালি used for forecasting. Logistic regression normally used for binary class classification task. So linear regression predict the numerical value, logistic regression predict the categorical value. You can see also the equation. So linear regression, linear representation is needed in linear regression, but for the logistic regression, linear representation is not mandatory. If it is, it can be or it cannot be. So that is the thing. Dependent variable for linear regression is continuous, and dependent variable for logistic regression is categorical. Any questions?
नो सर
No, sir.
Okay, great. Then we can move to the next concept called multinomial logistic regression. In multinomial logistic regression, we apply logistic regression for multi-class classification tasks. Normally, logistic regression is designed for binary class classification task, but now we are um, trying to apply these binary class classification classifier um, uh, to multi-class classification tasks. So then what to, then how to solve the problem? Here we have the solution. You can see there is a concept called one versus all or one versus rest classification. So you see the figure 1.7. So here you see we have three types of class: triangle, cross, and rectangle. So class 1 triangle, class 2 square or rectangle, and class 3 is a cross. So if we apply logistic regression to solve this three class problem, then we can't apply directly. So we have to do like this. Say for the first iteration, we say triangle is one class and cross and rectangle is another class. So it become a binary class classification problem. In second iteration, we can say triangle and cross is a one class and rectangle become another class. And in third iteration, we will see triangle and rectangle become one class and cross is another class. So it's a binary class problem. So after these three iteration, we can consider the average accuracy or average R square. We will talk about the accuracy error rate just now. So we'll do the result average. We'll get the average result. Is it clear? এটা কি বুঝতে পারছি? One versus all?
জি স্যার।
Okay. So how can we evaluate the logistic regression model or any classification model? So evaluating classifier performance. Okay. So we need to know these four terms. Like if you look at the table 1.8, then you will see we have four terms. One is called true positive, TP. Another one is a true negative, TN. Another one is a false negative, FN. Another one is a false positive, FP. So what is TP? True positive. So if the model, say for your regression, logistic regression model, correctly classify the positive examples, that means it's called true positive. So the model, they are correctly recognizing the positive examples, correctly classifying the positive examples, that is called true positive. If the model correctly or know the negative examples, correctly classify the negative examples as negative, that is called true negative. So true means the model say yes to yes, no to no. So that is called true positive and true negative. False positive and false negative is just reverse. When we say false positive, false positive, that means these are the negative instances. Model misclassify them and tells these are the positive examples. This is called false positive. Is it clear to everyone?
ইয়েস স্যার।
স্যার ক্যান ইউ স্যার আরেকবার একটু বলবেন?
ট্রু পজিটিভ মানে হচ্ছে পজিটিভ এক্সাম্পল গুলোকে মডেল সঠিকভাবে চিনতে পারতেছে, সঠিকভাবে ক্লাসিফাই করতেছে। যেটা ইয়েস সেটাকে ইয়েস বলতেছে, সেটা হচ্ছে ট্রু পজিটিভ। ট্রু নেগেটিভ হচ্ছে মডেল নেগেটিভ এক্সাম্পল গুলোকে সঠিকভাবে চিনতে পারতেছে, যেগুলো নো সেগুলোকে বলতেছে নো। আর ফলস পজিটিভ হচ্ছে মডেল ভুল করতেছে, নেগেটিভ এক্সাম্পলকে সে ভুল করে বলতেছে পজিটিভ, সেই জন্য ফলস পজিটিভ। যে সকল নেগেটিভ এক্সাম্পলসকে মডেল ভুল করে পজিটিভ বলে তারা হচ্ছে ফলস পজিটিভ। আবার ফলস নেগেটিভ হচ্ছে যে সকল পজিটিভ এক্সাম্পলসকে মডেল ভুল করে নেগেটিভ বলে তাদেরকে বলা হয় ফলস নেগেটিভ।
বুঝছি
বুঝতে
স্যার।
পারছি?
জি স্যার।
ওকে। সো আমরা যদি এই ট্রু পজিটিভ আর ট্রু নেগেটিভকে যোগ করি and divided by the total examples, then we'll get accuracy. So you see how to find the accuracy: true positive plus true negative divided by p plus n. P হচ্ছে positive examples, n হচ্ছে negative examples. So all the examples. So we can easily find the value of true positive and false positive by dividing total number of examples. That's called accuracy. So you can also uh, find the accuracy with the equation 1.23, 1.24, both are same. So 1.22 to 1.23 to 4, they are basically same. They mean same. So accuracy is the good performance of the model and the error is the bad performance of the model. So we also need to find the error rate. So equation 1.25. So in error means true positive plus false positive. So the examples, positive examples are misclassified as negative, negative examples are misclassified as positive. So the examples, total examples misclassified by the model is called error rate. How to find it? True positive plus true negative divided by total examples. That's called error rate. Is it clear?
ইয়েস স্যার।
Okay. So after calculating error rate or accuracy, we can also find true positive rate and true negative rate. Say for example, TP, true positive divided by only positive examples, is a sensitivity, or which is also known as true positive rate. Similarly, if you want to identify the true negative rate, that means true negative divided by n, which represent the specificity or um, um, uh, how many um, uh, negative examples are correctly classified. is called true negative. True negative divided by n. We can also find the value precision and recall. So precision is true positive divided by true positive plus false positive. So true positive is the positive examples are correctly classified by the model, and false positive means negative examples are classified as positive by the model. So model did the mistake here. Is it clear?
Yes, sir.
Right. So if you look at the table 1.9, then you can see these are the common parameters, matrices that we normally use to train the classification models like accuracy, recall, precision, F1 score, F2 score, F score, and F beta score. So you see the table 1.9. Is it clear to everyone? সবাই কি বুঝতে পারছে?
জি স্যার।
Yes, sir.
Last topic for today, that is called K-fold cross validation. আমাদের যদি শুধুমাত্র ট্রেনিং ডেটা থাকে, we don't have the separate test data, then what to do? How to test the model? Then what we can do, we can apply this concept of K-fold cross validation. Say for example k equals to 10, তাহলে আমরা বলবো 10-fold cross validation. So data setকে আমি 10টা ভাগে ভাগ করব, 9টা ভাগ দিয়ে ডেটাটাকে ট্রেন করব, রেস্ট 1 ভাগ দিয়ে ডেটাটাকে টেস্ট করব। তার মানে এই কাজটা আমরা 10 বার করব। তার মানে প্রত্যেক ইটারেশনে 9টা সাবসেট বা চাঙ্ক ইউজ হবে টু ট্রেন দ্য মডেল, জাস্ট একটা সাবসেট উইল ইউজ ইট ফর টেস্টিং। সো এইভাবে ইটারেশনটা চলবে কতবার? k টাইমস অর 10 টাইমস। তারপরে আমরা অ্যাভারেজ অ্যাকুরেসি প্রিসিশন রিকল কনসিডার করব। বুঝতে পারছি?
জি স্যার।
Well, that's it for today's class. So you see, everything is written very clearly, lucidly here in this lecture note, and this is I give a lot of effort, lot of time here to write all the things. Now it is your task to read them. So read line to line, word to word, right? আর এখানে এক্সারসাইজ দেওয়া আছে, এখানে অনেকগুলো এক্সারসাইজ তুমি আসলে সেম পাবা না, কারণ এগুলা ডেটা মাইনিং এর কিছু কোশ্চেন এখানে আছে। বাট ডোন্ট ওয়ারি, যে সকল টপিকগুলো ক্লাসে পড়ানো হবে শুধু সেই টপিকগুলোই মিডে আসবে, এমন কোনো আনসিন বা আননোন টপিক মিডে আসবে না। ঠিক আছে, সবাইকে বুঝতে পারছে?
Yes, sir.
জি স্যার।
আচ্ছা,
স্যার
কারো কোনো
একটা
কোশ্চেন আছে?
কোশ্চেন ছিল।
হ্যাঁ বলো।
স্যার যে কোশ্চেনগুলা মানে পিডিএফ এর মধ্যে প্র্যাকটিস করার জন্য দিয়েছেন স্যার, ওগুলাতে যদি প্রবলেম হয় আপনাকে জানাবো।
না, আমাকে জানাবা না, তুমি নিজে নিজে সলভ করবা। এখানে অনেক কিছু আছে, যেমন
আচ্ছা
ধরো
স্যার।
এনএসএমএল লার্নিং, অ্যাডাবুস, এগুলো কিন্তু পড়াই নাই, এগুলো ডেটা মাইনিং এরই। সো আমি ওই পার্টটা বাদ দিয়ে দিচ্ছি। সো এখানকার এই টপিকগুলোর উপরে যে কোশ্চেনগুলো আছে শুধু সেইগুলো দেখবা। যেমন ধরো ডিসকাস মাল্টিপল লিনিয়ার রিগ্রেশন, ডিফাইন দ্য ডিফারেন্স বিটুইন লিনিয়ার রিগ্রেশন এন্ড লজিক রিগ্রেশন। বুঝতে পারছো?
আচ্ছা স্যার।
মানুষ আপনি যেগুলো টপিক কভার করছেন ওগুলো টপিকের উপর কোশ্চেন গুলো দেখবে, এই তো?
হ্যাঁ, যে টপিকগুলো ক্লাসে পড়ানো হচ্ছে বা আমি আলোচনা করতেছি শুধু সেগুলোর উপরে মিডে কোশ্চেন আসবে। আর এগুলো হচ্ছে স্যাম্পল কোশ্চেন, মোস্টলি এই কোশ্চেনগুলো মিডে না না আসার সম্ভাবনাই বেশি। বুঝতে পারছো? যেমন
জি স্যার,
ব্রিফলি
বুঝতে পারছি।
এক্সপ্লেইন লজিক রিগ্রেশন, এটা পড়ানো হয়েছে। কম্পেয়ার লিনিয়ার রিগ্রেশন উইথ লজিক রিগ্রেশন, যে একই কোশ্চেন আবার রিপিট হইল। বুঝতে পারছো?
জি স্যার।
ওকে, আর কোনো কমেন্টস আছে?
অ্যাটেন্ডেন্স
বলো।
স্যার, অ্যাটেন্ডেন্সটা দিতে পারি না।
আচ্ছা দাও, আবার দেখো। নাম্বার 1,
না স্যার, আর একটু নিচে।
নাম্বার 8,
স্যার 27 মেবি।
নাম্বার 11 স্যার।
নাম্বার 11, 27, রাইট। আর কেউ? আর কারো সমস্যা আছে অ্যাটেন্ডেন্স নিয়ে?
নো স্যার।
আচ্ছা, তাহলে কারো কোনো কোশ্চেন আছে? এই এগুলো পড়ো, যদি না বোঝো নেক্সট ক্লাসে আমি আবার বুঝাই দিব। ঠিক আছে, ফিজিক্যাল ক্লাসে আমি আবার বুঝাই দিব। কেউ
স্যার
কিছু
ক্যাম্পাস
বলতেছো?
কি খোলা?
হ্যালো,
স্যার ক্যাম্পাস কি খোলা স্যার?
ক্যাম্পাস শুধু মানে ডিন হেডদের জন্য খোলা, সাধারণ শিক্ষকরা বাসা থেকে ক্লাস নিচ্ছে, বাট আমাকে ইউনিভার্সিটি আসতে হচ্ছে।
স্যার তার মানে অ্যাকচুয়ালি স্যার আমরা একটা ছোট ইফতার প্রোগ্রাম করতে চাইছিলাম।
কেন শুধু ইফতার প্রোগ্রাম করবা?
স্যার এমনি স্যার।
মানে এমনি শুধু শুধু করে লাভ আছে বাবা, বাসায় ইফতার
আচ্ছা।
করো। আর ছোট ইফতার প্রোগ্রাম করলে বাসায় করো। তুমি যদি ছোট 5 জন 7 জন, তুমি কি আমাকে ইমেল করছো? হ্যালো,
জি স্যার।
তুমি কি আমাকে ইমেল করছিলে বাবা?
জি স্যার।
আচ্ছা শোনো, তোমার যদি ছোট 4-5 জন নিয়ে ইফতারি করো তাহলে বাসায় করো, সেখানে ক্যাম্পাসে আসতে হবে কেন?
আচ্ছা স্যার।
ঠিক আছে। আচ্ছা, আর আমার যেটা মনে হয়, আমি যেমন পার্সোনালি প্রেফার করি আমার বাসায় পরিবার নিয়ে ইফতার করতে, সেটাই সবচেয়ে ভালো। ঠিক আছে। আচ্ছা, তাহলে কারো যদি কোনো কোশ্চেন না থাকে, কমেন্টস না থাকে,
স্যার
তাহলে
স্যার
আজকের মতো class শেষ
অ্যাটেন্ডেন্সটা
করি।
দেওয়া যাবে স্যার?
আবার বলো।
স্যার অ্যাটেন্ডেন্সটা দিতে পারি না স্যার, নেটওয়ার্কের সমস্যা ছিল বাইরে
আচ্ছা
বসে।
বলো,
স্যার
নাম বলো, আইডি বলো।
634 65 ব্যাচ 634।
দেখো তোমার সিরিয়ালটা দেখো, তুমি দেখতে পাচ্ছ
স্যার একবারে লাস্টে স্যার 33।
633। ওকে, এই যে
স্যার
দিয়ে দিচ্ছি, রাইট।
ধন্যবাদ স্যার।
ইউ ওয়েলকাম।
স্যার ক্লাসটা কি
হ্যাঁ
মানে
বলো।
আপনি যদি অনুমতি দিতেন